Hello. In this video we're going to be solving what are called differential equations. So these are examples of differential equations and we're going to be solving each of these in this video. Basically you've got dy by dx on the left as you can see, and then something in terms of both x and y. It doesn't have to have dy by dx on its own on the left hand side. In the last example you can see it says 2x plus 6 plus dy by dx, although that's easy enough to make dy by dx the subject. So why might we want to solve a differential equation? Well, they can be used to model things like radioactive decay, population growth, cooling curves, leaky bouncy castles, and so on. And we'll be looking at that in a separate video. But firstly, we're going to look at how to solve differential equations with variables x and y. And if we can write a differential equation in the form dy by dx equals f of x times g of y, i.e. a function of x times a function of y, then we can rearrange it to get all the y's on the left, all the x's on the right, and proceed from there. So we have the integral of 1 over g to the y dy equals the integral of f of x dx. So for example 1, we've been asked to solve dy by dx equals x squared times y cubed. So as it says in the box at the top, if we can write a differential equation in the form dy by dx equals f of x times g of y, then we can rearrange it and solve it. The equation we've got is already written in this form with a function of x, which is x squared, and a function of y, which is y cubed. So we can go straight to rearranging it. So by dividing by g of y and timesing by dx, we get the integral of 1 over y cubed dy equals the integral of x squared dx. In order to integrate 1 over y cubed, we need to write it as an index, so y to the minus 3. So we can integrate the y function by adding 1 to the index and dividing by it, which gives us minus a half y to the minus 2. And the integral of x squared is a third x cubed. So we get our final answer of minus a half y to the minus 2 equals 1/3 x cubed plus c. Now, although that is the final answer to this question, you will be asked to do things like make y the subject, perhaps, or to find the value of c if we're given the coordinates of a point, x and y. For our second example, we have dy by dx equals e to the power of x plus y, and we've already said that we'd like to write that in the form f of x times g of y on the right. Now we can do that because e to the power of x plus y is the same as e to the x times e to the y. So now we can divide by e to the y. That gives us 1 over e to the y on the left, which is the same as e to the minus y, and we can times by dx, and that gives us the integral of e to the minus y dy equals the integral of e to the x dx. To integrate e to the minus y, I just need to divide by minus 1. So I get minus e to the minus y equals e to the x plus c1. And the reason I've written c1 there is that I'm now going to times everything by minus 1. That gives me e to the minus y equals c minus e to the x. So that's a different constant, but it's the constant that we're going to have at the end of the question. So I'm going to make y the subject. So if I log both sides, log e to the minus y is the same as minus y, and I get log of c minus e to the x on the right. And then again, if I times everything by minus 1, I get y equals minus the log of c minus e to the x. For our third example, we have dy by dx equals xy plus 3y, and that is not written in the form of f of x times g of y. But if we factorize out the y on the right hand side, we get y times x plus 3. And now it is written in the form f of x times g of y, where f of x is x plus 3 and g of y is y. So divide by the y times by dx, and we get the integral of 1 over y dy equals the integral of x plus 3 dx. So the left hand side is ln y, and the right hand side is half x squared plus 3x plus c. Example 4 is just here to show you how complicated life can get if you want it to. Dy by dx equals 2x plus 7 times y over 2x plus 1 x plus 2. That is written in the form of f of x times g of y. So if we divide by y and times by dx, we get the integral of 1 over y dy equals the integral of something that we're going to write as partial fractions dx. I'm not going to read it all out, but in the bottom left box, we are working out what the partial fractions are. We get a as 4 and b as minus 1. And then when we substitute that back in for our integral, we get 1 over y integrated is the integral of 4 over 2x plus 1 minus 1 over x plus 2 integrated. So The integral of 1 over y is ln y. The integral of 4 over 2x plus 1 is 2 ln 2x plus 1. The integral of 1 over x plus 2 is ln x plus 2. And at this point, we'd normally write plus c, but I've written plus ln a because every constant is a logarithm of another constant. And the reason I've done that is that every term then is a logarithm. So the left is still ln y, but on the right hand side, if we turn that coefficient of 2 into an index for the 2x plus 1, we divide by x plus 2 and we times by a, we get a single logarithm on the right of log of a times 2x plus 1 squared over x plus 2. And if I have log of this equals log of that, then I can cancel out the logs and write this equals that. So y equals a times 2x plus 1 squared over x plus 2. In example 5, we're going to work out the value of c, or a in this particular case, using a coordinate. So dy by dx equals tan y tan x. That is written in the form of f of x times g of y, where f of x is tan x and g of y is tan y, so I can divide by tan y, and 1 over tan y is the same as cot y. So I've got the integral of cot y dy equals the integral of tan x dx. The integral of cot y is ln sin y, the integral of tan x is ln sec x. I've written plus c, but then I've said, oh, let's let c equal ln a, because then everything's in terms of ln's. So log of sin y equals log of sec x plus log of a. So on the right hand side, that's the same as log of a sec x. So if I have log of sin y equals log of a sec x, I can write that sin y equals a sec x. And as we see, we've got a point, pi over 3, pi over 2. So if we substitute x equals pi over 3 and y equals pi over 2, we get sine of pi over 2, which is 1, is equal to a sec pi over 3. That's a times 2, so a is a half, which means that sine y is half of sec x. And finally, example 6, 2x plus 6 plus dy by dx is equal to 3y plus xy. So it's definitely not written in the form of f of x times g of y on the right equals dy by dx. So we can start that off by moving the 2x and the 6 over to the right hand side. So we've got dy by dx equals, but it's still not in the form f of x times g of y. However, as you can see, we can factorize the right hand side. So we get x plus 3 y minus 2, and that is in the form of f of x times g of y. So if I divide by y minus 2 and times by dx, I get the integral of 1 over y minus 2 dy is equal to the integral of x plus 3 dx, from which we get ln y minus 2 is equal to a half x squared plus 3x plus c.